Welcome to Executives at the Edge, a podcast brought to you by MEF. I'm your host, Pascal Menezes. Join me as we explore thought-provoking perspectives from the leaders and changemakers who are propelling enterprise digital transformation forward. I am really so excited to have Frank Cittadino from Zayo Group, and he's the SVP of Edge Services. And today we're going to cover a lot of discussions on the edge. Frank, welcome to this episode. And if you can please tell us a little about yourself and about the Zayo Group itself.
Hi, Pascal. Thank you for having me. My name is Frank Cittadino. Currently the SVP of Edge Services for Zayo Group. A little bit about me and my background. About 10 years ago, I started QoS Networks, which is an SD-WAN managed service provider focused on deploying, managing, and ultimately, driving better productivity for customers using SD-WAN. Our differentiation in that company was really to drive a software layer on top of the SD-WAN to drive consumability for large enterprises. As SD-WAN grew and service providers adopted the technology, Zayo was highly focused on deploying bandwidth solutions globally, using lit services and dark fiber, and realized, after they were taken private, in a private equity deal a few years ago, that they wanted to continue to expand the enterprise focus that, an acquisition of QoS Networks made sense to expand into SD-WAN. Subsequently, we joined Zayo and we had a very successful year, delivering edge solutions, delivering SD-WAN to Zayo's customers and to new customers that we've sold together. So excited to be a part of the go-forward story for Zayo. Zayo's history, is approximately 15 years old, and the thesis of Zayo was, expanding fiber networks throughout the United States and Europe and really following the multi-cloud movement, and driving infrastructure, which is, layer 1 and 2 solutions to connect cloud players around the world. Largely very successful, capitalized on underserved routes that had, not a lot of capacity on them by the incumbent players, and you had a company that was then born of 46 acquisitions of fiber optic networks throughout the United States and Europe. So filled a fantastic need. That was stage 1 of our growth, and kind of stage 2 of our growth is going to be expanding into the enterprise and doing a pivot into driving, I would say, next gen solutions in our packet or cloud network, right? And then driving solutions in the edge, utilizing the network that's in place today.
Well, thank you, Frank. I think it's very impressive what Zayo Group has done. And I think what most of our listeners want to understand is there's so much noise about the edge and, multi-access edge compute and edge computing. And really, at the end of the day, how do you define the edge? Because there's so many definitions.
Yeah, it's a great question. We define the edge as anywhere a digital experience is consumed or a service is delivered. And so if you kind of look at the marketplace today, there's many different edges, and everybody kind of has an edge, right? You have near edge, far edge, mobile edge, compute edge, right? Network edge, customer edge. And these are all things around where the edges kind of bump into another network. So everybody's got a definition of how they really define the edge. I think here at Zayo Group, one of the things we do really well is we bring together kind of 3 different edges, which is the edge of where the experience of that application is delivered or consumed. B, which is the network edge, which is the middle mile solution where we have our fiber and the ground connecting data centers. And then C, which is the cloud edge, right? So if you take all 3 of those and put them together, we're the 8th largest internet carrier in the world, or 8th largest network in the world. And when we bring those together, we're combining lots of different edges. We enable the mobile edge with our fiber to the tower business. We enable the data center edge for our multi-cloud customers and players. We enable the edge or the hybrid edge where customers are taking their people out of buildings and having them be hybrid or from home, the hybrid workforce edge, right? Or it may be the mobile edge where customers are driving in a car, where there's a SIM card in the car driving around connecting to a network. Zayo's, front and center connecting all of that. So we play a pivotal role in internet connectivity in America.
So one of the things I think many listeners struggle, and I think many people struggle with, is what are these use cases that drive the edge? I know it's all about delay and also some bandwidth, concerns. But, you talk about Industry 4 initiatives, smart factories, all these smart warehouses, connected vehicles, you're going to see smart glasses. So can you kind of give some use cases why the edge is becoming prevalent and why everybody's caring about it now?
Yeah, well, you mentioned, multi-edge, Mac, and I wanted to tie that back briefly. Edge compute as a whole is really an industry solve for a distance and reliability problem, where we want to take the core compute from the cloud, which is I would say, hyperscalers, and push that more towards where the applications are consumed, right? Typically, this has been done by content delivery networks, but that's not really enough. That's delivering pieces of an application. So edge compute is really pushing that down and closer to where, these IoT devices, which you just mentioned, are consuming them. And that can be a car, a camera, digital glasses. I mean, what you name it, all of these things are consuming either services or microservices from some compute cluster somewhere. And the big thing has been, how do we improve latency to drive real-time decision-making at the edge? And so people are pushing compute closer into the metro, into regional networks to try to lower that down, so it's not having to go such a far different distance and be routed, between a bunch of networks, driving up latency and things like that. So that's the current use case. I think, one of the things we see in factories or manufacturing, which is a clear-cut use case, which is, you're stamping bumpers and, as the machine comes down, if your hand's in the way, can it stop the machine to prevent your hand from being chopped off? Can a car driving down the road, communicate with a server somewhere and make intelligent decisions based on routing or something being in the road? I don't think we're there yet today, per se, in how we can do real-time compute, but I think we're really close on the near real-time compute, which is your communication suite of products, right? That's come a really long way. And, the hybrid nature of work was really enabled by our communication and collaboration products out there that really were developed and conquered in almost real time, companies kept working during a pandemic and didn't need to be in an office. So you have this vast change of how, people around the world are working and being effective out of the office, driven by this solution, which is pushing these edge solutions closer to the edge. If we think about fiber to the tower, hotspots, and Internet of Things, we can think about it and say, how is this all going to work with things in the cloud like Google and Azure? Well, multi-edge compute and edge compute is getting closer to where it's being consumed and enabling it. I think it's going to get closer for the real-time processing sometime in the near future, but that's still under development.
So for 2023, then, what are the actual use cases? Where do you see the edge going?
Yeah, the edge is really focused on security in 2023. I think SD-WAN came out and kind of revolutionized MPLS 5 or 6 years ago. Right now, there's two major things going on. Security, I would say mobility, right? And mobility is really tied together with the hybrid nature of work, right? So as people transition out of the office, how do we drive mobility and do it securely? That's a big topic for 2023. Further term, edge compute's going to continue to grow legs. It's just not quite there yet. We've done a lot of work in UCPE and VNFs and trying to put compute, smaller compute clusters on customer prem, right? Things like that. It hasn't worked out where the investment into the device itself has given enough value to the customer to pay the price. So we're thinking about how we push edge compute out to the customer site or closer to the customer site. But in 2023, largely, the world is shifting into SASE a little bit more and still staying in, I would say, regionalized compute instead of distributed compute. And spending a lot of time securing that network, I think, is where 2023 is going to land. And you have companies there, that are making a lot of investments in security. You've got companies in SD-WAN like Cato Networks and, VMware who are focusing on security. And then you've got a kind of new school set of companies that are coming out in hybrid work, companies like CloudBrink, new startup, launched their Series A that takes all the best features of SD-WAN, instantiates that on a laptop, right? So you get all the performance benefits, all the security benefits, and all the multi-cloud benefits without any hardware. So really reinforces that, hybrid is here to stay. And I think that's a really interesting use case. So I'm assuming more companies like that will continue to pop up.
Well, Frank, that is actually a very good use case because I think you're spot on that SASE is definitely where the market's going. And I think it's still in a confused state. But cybersecurity, I was just reading an article by 2030, 20 something, 27, it's going to be $11-12 trillion economy. And everybody's concerned about that. And I think it's a very, very important use case. And certainly I think what you're saying is having a security in the cloud model, which is SASE, Secure Access Service Edge, or SSE, is what you're talking about. And so you need edge computing to do that because you don't want delay, right? And now, will Zayo Group actually deliver a SASE service and also an edge product for other people to put their SASE services on? Or that, I'm kind of confused.
Yeah, a little bit of both. We're looking at a wholesale model where customers can use us as a middle mile for their SASE services. Obviously, we have one of the world's best networks, so we feel like we can deliver, high performance networking securely. So I think that's one aspect, right? We're really interested in using the features from VMware on their NNIs, right, where we can tie right into their network and federate the gateways, so customers can use it, carriers can use it, things like that. So that's one aspect of it. But you hit on another topic, which was how do you use edge compute to drive a better hybrid workforce environment? And I think that's where the newer school players are going to come out and say, well, we're going to use compute in the local metro areas to deliver a really high level of service back to the public cloud. So think about like this, where a user would connect without a device to the closest compute node in a metro, which is edge compute, jump onto a network and then get routed back to a larger compute data center, using what's the concept of an ephemeral edge. And I think that's what we're talking a lot about now is how does compute spin up, spin down based on demand in the network edge, or I would say in the distributed edge, versus going back to a static data center somewhere and then getting routed. So I think the ephemeral edge concept is going to be kind of key going forward.
I think that's a very good label for where the edge is moving. And I think also, if you think about it, that the edge is, as you said, is distributed. And I think, your great use case of SASE is really great for 2023. But the bottom line is as you put on 5G, glasses, smart glasses, and all these 5G use cases that are consumer-based, or even, other 5G areas, private 5G, that it's going to need the AI ML processing to happen right then and there. So it gets back to AI ops. So what is, AI ops? Like AI, we just talk AI ML and have deep neural networks to be able to infer. But now we're using inference and AI to do operations. So why is that so important for the edge? And what is AI ops? And first of all, what is AI ops? Why is it important to the edge? And what is the future towards this kind of operational network management model?
Yeah, great question. So, AI ops is an AI approach to standard network operations. And so one of the things we look at is in the edge, you have, thousands of sensors, beacons, right, devices, and all of these things are talking and doing different things at different times. And one of the things that we look at is a correlation between them to say, what is going on in the network and why is it happening? And then using AI to guess at a problem based on different things that are going on within the network. And that could be packet level issues, that could be heuristics, that could be several different things that are happening. We take all of that information, we compile it into a database, we look at it, and then we run, predictive analysis against it, right? We're looking at what has happened before. We're taking historical analysis and we're saying, this is what happened before when we saw these markers. This is what we predict is going to happen now. And then we run AI against it, and we run when we look at the AI and the correlation, it says we've correlated this to that, right? And we're popping up new correlation patterns that we never saw in massive contextualized data sets. So as you talk to have, 50,000 cars on the road in a city, right? We're looking and can take data from the 50,000 data points and say, we've correlated to this main root cause, and we get to faster root cause analysis of a problem. We can get to predicting what's going to happen in the network today based off certain markers we've seen and which we think will happen. We also tie that together with synthetics. And synthetics are, running transactions over a network to understand current health. We take that information tied together with historical patterns, and we kind of look and we say, this is what we think is going to happen. And from that, we'll get contextualized correlation and say, we've correlated all this stuff together, and this is where we think it's going. And then we take predictive action, and we can say, we're going to reroute your traffic based on what we think is going on, what we think is going to happen, and what we think you will encounter today. And that is really the AI piece to say, we're actually making decisions in a highly proactive manner that's taking many different things into account and making guess at what we think is going to happen. And that AI model is getting a lot more accurate. I'd say when we first started, those things were 50, 60% accurate, right? Half the time it would route you through Alaska. Now as we kind of look to models like that, we could be significantly more accurate because we're getting better data over time.
So are you really training these neural networks to be able to look at the inference of what you were seeing as traffic abnormalities and how to self-optimize the networks? Or are you buying this technology? Because it's very complex to train these data sets for these patterns that you're looking for.
In a lab, Pascal, yes. We're trying to, definitely not in production today. Those things are really, really hard to do, right? But in a lab, yeah, absolutely. We're looking at ways to, as we correlate information across our edge solution, right, and all of our deployed devices, we're looking to say, if Comcast has an outage, can we not peer with Comcast and peer with someone else? Can we deliver that traffic in another way? Can we guess better at it, right? That's a use case. Or is it, hey, JP Morgan Chase has latency on a route here. Can we move latency to somewhere else that's going to give a similar level of latency? Or is it, something along those lines where a big client would do something like that?
Yeah, totally makes sense. And very, very complex to do. And I think that's where we're all moving to. Now, think about innovation at the edge. What is something that excites you there? We talked about a lot of these areas and use cases, but what's really exciting? SASE is exciting, but there's a lot of great use cases in IoT and AI/ML, and certainly, smart glasses coming in very, very rapidly with metaverse. So what do you think? What's innovative and what's exciting?
It's hard to ignore AI. I think this world is really going to, there's a lot of fanfare and buzzwords in AI right now, and so it's hard to ignore AI. I think I'm really excited about driving AI back into networking. I think it's really exciting. I think that's number one. Two is how do we leverage a better multi-cloud between hybrid cloud, private cloud, public cloud. I think it hasn't been solved. I think there's a lot of investment going into multi-cloud, secure multi-cloud, connectivity between Aviatrix or an Alkira or Proximo, things like that. So I think that still has not been solved well. And that includes the edge, which is the edge cloud, right? As we distribute, as edge becomes more distributed and pushed out of the data center, how is that going to get solved? Kubernetes does a really good job of spreading out the compute, but then how do you take that, and really say, all right, well, we're going to run microservices everywhere. And then how do we run multi-cloud compute across it? That becomes incredibly difficult. So I think that's pretty exciting, still the multi-cloud play. But I think the last thing that I get really excited about is kind of around IoT and all the things that you can now do inside of a retail store and you can now do inside of a showroom, right? As we move away from the stockroom experience when we go to buy something in a store to a showroom experience, we're expecting pretty lights, high connectivity, lots of touch, lots of sensory input. How do we drive a lot of that when we go into a store to drive a really solid experience? And so I think it's done with a lot of things you mentioned in IoT. If you walk into a standard, store, there's probably 50 sensors, 100 sensors, 50 beacons, right? That are all enabled by IoT. They're enabled by edge compute, right? That require a strong network behind it, require high security behind it. You start to add AI to that and you can get really, really exciting with delivering a solid solution to an enterprise. So I'm really excited to continue to innovate these things at the edge. There's a lot of different things that go into delivering that reliably, which are more of the operations piece you mentioned, Pascal. But I think the innovation piece is really driving AI into a better showroom experience. When you walk in somewhere, it's highly interactive, highly customized and tailored to you as an individual, and not so, I would say, standardized and broad.
So Frank, what you're really describing now is we're going from specialized AI to general AI. I think the open AI and what you're seeing with, chat GPT is the idea that instead of specialized AI, where you're training to specific patterns, it makes the correlation. If you think about what you just described the store, I have to now have computer vision to recognize what's going on, have video analytics that is AI driven, that then ties into sensors. And this generalized AI, we're not quite there yet. And I think the open AI, initiatives we're trying to get to generalized AI. Well, what's your thoughts on that?
Yeah, that is a great question. And you're exactly right. We had specialized use cases for AI for the past 4 or 5 years, right? In the last 2 years, it's really gained a lot of momentum. I think there is a concept here that we continue to explore, which ChatGPT does, which is moved into the general AI movement, right? Which is using AI, I would say, in a multi-domain way. So as we try to look at the different domains of where AI could be used, we had it in a singular domain before, let's just say in operations, right? How do we use now AI across domains to make better decisions where we're inputting to the model AI-based decisions downstream? So before we had a human consuming an AI-based platform one-to-one. Now we're going to have AI feeding an AI platform. And as you kind of go down, it's going to continue to build on itself. Where I get most excited in generalized AI is when we get into kind of video processing AI for the AI to understand what's going on and give an input to a network system, which is based on AI to give an input to a human to make a decision. I think the way that the AI is going to interpret video, sound, interaction will be key in how we have responsible and safe AI, because I think that's a very large piece to what we do, is being responsible with our AI to say, the AI to say, I saw this, well, a human saw that. Who's right? And I think there's a lot of different ways that model continually needs to be trained to really deliver a high value. So you're exactly right on. I think the most exciting piece is where can we take AI in 2023, which I still think is super nascent and new, but where could we take it to drive better networks, better edge decisions? You know, Pascal, tying this back, we made edge decisions on where we were going to put our network years ago based on where customers said they needed a data center facility. We want to change that model in 2023 plus to say, we think you're going to want to put a data center in Melbourne, Florida, something like that. And they're going to say, we don't have nothing there, but we're going to be like, yeah, but in 2 years, the population is going to be there and you're going to want it. Here's all of this data set that we're forecasting to happen and you don't even know what's going to happen yet. That's where we start to get really exciting to say, we're going to build things that you don't even know are going to happen. And we start to get 2, 3, 4 years ahead of, our customers and really speculate. And if we're right, I mean, it could be a total game changer for how we deliver networks.
Well, Frank, always a pleasure to talk to you. So insightful that I think this whole episode was so incredibly precise about the edge and, specifically at the end here with AI. So I want to thank you, and our audience, I'm sure, thanks you. And I'm looking forward to seeing you again sometime in the future. So thank you, Frank.
Thank you, Pascal, for having me. I appreciate it. I look forward to chatting more in the future and, continue the conversation on these, highly technical solutions.